The periodic table is organized in order by atomic number. The atomic number is the number of protons in the nucleus. The grid of elements consists of 18 columns and 7 rows. In each row, starting from the left to the right, the element is more stable, as in they have more valence electrons. On the farthest to the left, they are very unstable, and to the right, they are very stable. The groups for nonmetals are noble gases, halogens, and other nonmetals. The groups for metals are alkali metals, alkaline earth metals, lanthanoids, actinoids, post-transition metals, and transition metals. There is one more group by itself, and that is metalloids, an element that is between a metal and a nonmetal. The stability of an atom is determined by how many valence electrons there are in the outer shell of the atom. If an atom has few valence electrons, then it will try to get rid of its electrons to use its inner shell as its new outer shell full of valence electrons. If an atom has a lot of valence electrons, then it will try to receive the needed electrons to have a full outer shell.
I'm chlorine and I have 7 valence electrons.
I'm sodium and I only have 1 valence electron.
I have 7 valence electrons, or articles of clothing, given that I am an atom. I need 1 more to become a very stable element. Is there anyone that can do that?
I have that 1 electron. Here's my 1 valence electron.
Gracias. Now my outer shell is full of 8 electrons.
Now my inner shell is now my outer shell, and I have 8 electrons. He got the 1 valence electron because his electronegativity is greater. So, he got the 1, and then my inner shell becomes my outer shell. And this is what happens when the atoms are happy.
I have 8 electrons. I have 8 electrons. I have 8 electrons.
There is an odd group, though, and that's the noble gases. The noble gases include helium, neon, argon, krypton, xenon, radon, and unoctium. All of the noble gases have their outer shell full with 8 out of 8 electrons possible. Therefore, they do not give away or receive any electrons.
There are 3 different types of bonds: ionic, polar covalent, and non-polar covalent. Ionic is when there is a complete transfer of the electrons from one element to the other, and when the electronegativity difference is greater than 2.1, just like how his height is substantially smaller than my height. Polar covalent bond is when there is unequal sharing of the electrons, and the electronegativity difference is between 2.1 and 0.4, just like how our height is not too substantially big or too substantially small. Non-polar covalent bonds is when there is equal or almost exact sharing of electrons between 2 elements. That means that the electronegativity difference is less than 0.4, just like how our height is almost exactly the same. Compounds are formed by the chemical reaction and fusion of 2 or more atoms. Compounds can be formed by the fusion of a compound and an element, 2 compounds, or just 2 elements. Now, of course, compounds, since they can be created, can also be destroyed, just like how H2O can be broken down into hydrogen and oxygen by the use of electricity, and then easily they can be put back together. Atoms and elements bond because of their electronegativity. Electronegativity is the force that causes certain elements to give away or take electrons from another element. This causes them to bond because if you take an element that has 7 electrons and an element that has 1 electron, the element with 7 electrons is going to have more of an electronegativity that is going to pull that 1 electron and cause the 2 to bond, just like this. And then once they bond, they form a compound, which cannot be broken down unless it has certain circumstances.